Hi, now I'm going to solve a problem which is printing all the leaders in an array. Any element is a leader if it is greater than all the elements to its right, and also by definition, and also by leader definition, the rightmost element is always a leader. The rightmost element in an array is always a leader. So let's take an example and see what this actually means, and find out the leaders in the example. So to start with, index 0 in this example, we have 16. So for 16, the rightmost elements in the array should be less compared to 16, but we have 17 which is greater than 16, so 16 is not a leader. It cannot be a leader. Moving on to the next element, 17. For 17, the rightmost is 4352, where all the elements are less, so 17 is a leader. So the next element, 4, 3, 5, 2 are the rightmost elements, not the rightmost, are the elements to its right. But there is 5 which is greater than 4, so 4 cannot be a leader. When it comes to the next element, 3, even for 3, 5 and 2 are to its right, so even 3 can't be a leader. But when it comes to 5, we only have 2 to its right, and 2 is less than 5, so 5 is a leader. And by definition, 2 is the rightmost element in the array, so 2 is also a leader. So this is how we'll find out whether a given number is a leader or not. So 17, 5 and 2 are considered to be leaders for this example. Okay, so now how do we implement this? Like using a programming language, how do we write a program for any given array? How do we find out the leaders in that particular array? So as I think of the problem, I have two solutions in my mind. So one solution is similar to what I was trying to explain here, like taking a particular array element and traversing to the rest of the array to see whether all the elements to its right are lesser or not. So doing this for every other element by traversing the entire array. So if there are n elements, we would traverse the array n number of times. Not exactly n number of times. It is like the worst case scenario. If the greater number is at the last element of the array, then obviously we would traverse the whole array and see that, suppose instead of 2, if it is 20, then for 16, to see that it is not a leader, we have to traverse the entire array. Like this is like the worst case scenario. And and the best case scenario could be, like if 20 is in place of 17, instead of 17, if we have 20 here, so we would have directly find out we can directly find out that for the first time we enter into the array, we found out 20 is greater than 16, and we don't have to traverse the entire array. But still, there are for to to take into the worst scenario, considering the worst scenario, we would traverse, like if there are n elements, we would traverse n times the entire array. So the solution is O of n square, because for every element we'll be traversing the entire array. So this is a plausible solution, but I'm thinking, can we do better? Like, is there a solution which will give us, is there a way we could find out the leaders by traversing the array only once? So like the second approach that I am talking about, if by traversing the array only once, the time complexity for that solution would be O of n. But how are we going to do that? Remember in the problem description, we also had a statement saying that the rightmost element in the array is always a leader. So instead of traversing the array from starting to end, why not traverse it from the end to the starting, like in a reverse direction? So this means that, because we already know that the rightmost element is always a leader, okay, so in this case what we can do is, like in this second solution, so we'll start with number 2, and we know that 2 rightmost element is always a leader, so we'll print that, or we'll say that it's a leader. And we'll also put it in the variable max. Max means, for this implementation I'd be needing this variable max. I'm storing that is the maximum element in the array. I'm assuming like this would be the maximum element. So first time my max would be 2. Okay, so first I'll print it, and then I'll print the element, and then I'll set the max to that array of the last element. Okay, and then I decrement the counter, now my eye is pointing, decrement the counter variable, and now my array element is 5. So now I'll check whether this 5 is greater than max. It is. So when any element is greater than max, all we do is we print that element and we store that element in the max. So now my element is 5, and again we are printing it. So after that again my counter is decremented. Now I'm here. I'm checking, is 3 greater than 5? No. So I won't be doing anything. So I'll move forward here. So is 4 greater than 5? No. So again my counter is always decremented, and I'm moving here. Now is 17 greater than 5? Yes. So what I'll do is I'll print 17, and I will change my max to 17. Okay. Now I am going to decrement my pointer, and now it is 16. Is 16 greater than 17? No. So it is not a leader, and we are not printing any of this. So we will be decrementing till we reach the 0th index. That is our stopping point. Because we'll be like, if we start from the beginning we'll do till the end of the array, but because we started at the end, our ending point would be stopping at the first index. So by doing this, if you observed it, we didn't traverse the entire array n number of times like in the previous case where n is the length of the array. We only traversed it once, because with the help of the max variable we always kept track of what is maximum, and because we were traversing it from the right side, we always knew there is no other element which is greater than the max. So if it is greater than max, then that element would obviously be a leader. Like in our case 2, 5 and 7. Of course we will be printing it in a reverse order when compared to this, but all we care is whether we are able to print leaders or not. So my efficient solution would be O of n. Um, Solution, and this is how in Java this is how we write the program. So in this case I'm writing my function is find leaders, and I'm passing array as my input, array as my parameter. And in the beginning I want to check all the negative cases. So uh, my according to my understanding, I want to check whether whether there is no element in an array, or the array is pointing to null. So these are the two things that I'm thinking could be the negative cases in this array. So so I'll check for these two conditions. If array dot length is equal to 0, meaning I'm checking if the array is empty, or if the array is null. So I'm going to print out saying either array is empty or null, and I'm going to and the control is moved to the next line, which is return. It is saying that if there is a return statement here, it means that none of this code is going to execute. The control will come out from this function. I mean, whichever part of the statement is calling this function, control will go back there, because return is placed inside if. In our case, our array length is 6. There are 6 elements in our array. So none of this statement is valid. So it will enter here, and it will save that length in a variable n. My n is 6, and I'm assigning a max variable. Like here I'm assigning a max variable and storing the n minus 1. N minus 1 is 6 minus 1, 5. My last element of the array, I'm storing it in the max. I'm assuming this as my maximum element. So let me trace this program by saving all the values for those variables. And after saving it, I'm trying to print it here. So whatever my values are, I'm printing it here. So my print values, so first time I'm printing 2. Okay, now because this is println, my console control will all, it's at the new line. So next time I'm printing in the new line. So now the next statement is the for loop, where I'm initializing I is n minus 2. My n is 6, n minus 2 means, because I already know this is max, I don't have to visit this again. So n minus 2 will go to 4. So my I value is 4. So is 4 greater than or equal to 0? Yes. So now it will come here and check if array of 4 is greater than max. My array of 4 is 5. Is 5 greater than 2? Yes, it is greater than 2. When it is greater, what I'm doing is I'm printing that number 5, and I'm assigning that number to max. So my new max value is 5. Okay, now after this statement, my I value is decremented. My I value is 3, and the condition 3 is greater than equal to 0, the condition holds good. And I'm coming here, is array of 3, is 3 greater than 5? No, it is not greater than 5. So it will come out of the if statement and decrement the I value. So now I value is 2, and 2 is greater than equal to 0. That is also true. So now I'm checking if my 4 is greater than 5, but 4 is not greater than 5, so it will decrement the I value is 1. So now it will check, is 1 greater than or equal to 0? Yes. And now it will check array of 1 is greater than max. My array of 1 is 17. Is 17 greater than 5? That's true. So it is greater, so it will print that statement and assign it to max. I'm printing 17 here, and I'm assigning 17 to the max. Now my I is decremented, so it was 1 and it became 0. Is 0 greater than or equal to 0? Yes, it is equal. So array of 0 greater than max? Is 16 greater than 17? No, because it is not equal, not greater. So I is decremented. Now I value, so it was already decremented, I forgot to write the value. Now I value is minus 1. So is minus 1 greater than 0? No, it is a lesser value. So it will come out of the for loop, and that's it, that's the end here. So by the end of this program, I am able to traverse the entire array and give all the leaders here. So this is my implementation of, I mean, efficient implementation of printing all the leaders in an array. Thank you.